Alright, so let's take a look at actually solving equations involving logarithms when the directions want us to really find the value of the variable. They don't just want us to rewrite it. So again, if you haven't watched the video previous to this one, then please do that. It will help, I think. Okay, we're going to solve this equation. Well, the very first thing I want to do is I want to rewrite it in exponential form and see if that helps me, right? So I'm going to rewrite it in exponential form, which would be 2 to the third is equal to x. And boy howdy, did that help me, right? 2 to the third, well that's just 8, and that's what x is equal to. So solved, right? I did exactly what it was asking me to do. Let's take a look at the next one. If I write it in exponential form, I have x to the second power is equal to 7. Okay, well, this isn't really a difficult issue, right? We've had lots of x squared practice in our algebra work, so we're going to take the square root of both sides, and so then I get that x is equal to plus or minus. Well, I don't want to put a decimal in, right? I want the exact answer. Okay, that's always the best thing to do, is to give the exact answer when you're not sure. So plus or minus the square root of 7. Now, if it's a real world situation where you're trying to, find out values of things and build something or calculate a distance or something, well, of course you want to get that into a decimal so you know what you're really talking about. But if it's just something like this, out of context, and we just really don't know what the context is, we're going to use the exact answer. Or, pardon me. Oh, here we go. 3 to the x power is 10. Now, if I rewrite this in logarithmic form, that's going to look like this. And is that helping me? The next thought is, gosh, no, that made it harder to understand. So here's what we're going to do. Then what we're going to do next is we're going to go, well, gosh, can I get the bases to match, right? Because that's the only thing that we have in our little tool of, our little toolbox here. Can we get the bases to match? Well, no, I can't get 3 and 10 to be rewritten as two bases that match. So the answer to that is no. So what I'm going to have to do is I'm going to have to just wait until I have more information. Wait until I have more tools in my little toolbox to actually find the x value. I could guess and check with a calculator, but that's not what our goal is here. So just realize that the only way we can at this point solve something like this is to get the bases to match, and they're not going to. Okay? So we're going to hold off on that one right there. I put it in here just to show you, well, what happens if we have an x floating right up there and we can't get the bases to match? Well, you'll find out soon enough. Okay, so let's recap. We had an x in this spot, right? The argument spot, no big deal. We had an x in the base spot, no big deal. Okay? All right, so here we go. And then again we have an x in this spot right here, and when it's in that spot, then basically we have this situation, and again we can't move forward until we have more information. Now, here's what I'd like to do before we finish this last example. I'd like to talk to you about this one-to-one property we've mentioned before. But here's what I want to ask you. Let's hang on. Let's wait on this one for just a second. Let's just wait for just a minute. Now, I would like for you to come over here and take a look at this. If I write log base 4 of x is equal to log base 4 of 3, and I ask you, what is x? Okay? Wouldn't you know what x is? Of course you would know what x is, because if you look at the logs that match, the bases match, and the arguments would have to be equal to one another. So this is obviously a 3, right? Let's look at another example, and that would be this. If I have the natural log of 5 is equal to the natural log of x. Well, that just means, right, that the bases are matching. That's log base e of 5. That's log, I don't have to always rewrite this, but I'm showing you, reminding you all. Okay, so wouldn't x have to equal 5? Of course it would. So this right here, folks, this stuff is the one-to-one property. And the one-to-one property allows me to set arguments equal if the bases match, if the logs and the bases match. So let's take a look at this one right here. No longer do we need to wait on this one. What do we know we can set equal? We know that we can set this equal to this. So here we go. There we go. Easy, right? It's not that the logs are canceling out. So please don't think these cancel each other out. No, it's just a property called a one-to-one property. So now, it's no longer a log problem, right? It's now just an algebra problem, or a problem with just plain old using algebra 1 and 2 without logs. So let's just take a look at getting this all on one side, right? Because we have these two things that will not add together ever. So I want to get them on one side equal to 0. Now I'm going to just factor out. Right? There's my next step. And now I'm going to do what? I'm going to go ahead and set each of those factors equal to 0, and I'm going to solve. So here on this one, I've got x squared is equal to 2. I'm going to take the square root of both sides, and I get that x is plus or minus the square root of 2. Now, when we're dealing with logs and solving logarithmic equations, we must go back and check our answers. So I'm going to write this really largely in red. Must check answers. Okay, so you must check answers. So let's take a look. What would happen if I put a 0 back in to this right here? I'd have the natural log. Let's take a look. This is my checking. Alright, so I'd have a natural log of 0 equal to the natural log of what? 2 times 0. So I'd have the natural log of 0 and equal to the natural log of 0. What is the natural log of 0? Guess what? Put it in your calculator. It's undefined, right? That's just like saying the natural log of negative something. Let's put it in. The natural log of 0. Uh-oh, error, domain. You see that right there? The domain, error. That means that 0 is not even in the domain. We can't do that. So guess what? That means that that one is not valid. Okay? All right, let's do this. Let's put in, okay, let's check this next one. Natural log of the square root of 2 cubed is equal to the natural log of 2 square roots of 2. Okay, so what is the square root of 2 to the third power? Well, that would be 2 square roots of 2, correct? So let's see, is this going to work? Well, do these two values give me an actual, this is natural log of 2 square root to 2, does that give me an actual value? Yes. And is that going to be the same as that? Yes. So this one works. That one works. Let's check the very last one. Okay? I'm going to put it right over here. I have the natural log of negative radical 2 to the third power. Let me put that in a couple of those. There we go. And then we have natural log of negative 2 radical 2. Do you remember what happened? Let's go back here. Let's go back to the calculator. Remember what happened when we tried to put the natural log of a negative? Let's just go, I don't know, let's just put negative 2. Forget about the fact that it has a radical. Just put a negative in. Uh-oh, non-real answer. Okay, so guess what? This is not real. This is not real. So guess what? We have to cross out the fact that there's a negative. You can't ever take the log of a negative, right? And so your only answer in this one that actually works is the square root of 2, the positive square root of 2. So x is the positive square root of 2 is the only one. Okay? Hope this was helpful, and thanks for watching.